Hello everybody, this is Mr. Longo, and this video is going to introduce you to two special right triangles. Now, at this point, it is absolutely essential that you have good radical skills. You need to be able to multiply and divide and simplify radicals for this to be successful for you. So, what we're going to do is start with the 45, 45, 90 right triangle. And to show you where this comes from, if we were to do the Pythagorean Theorem to find the hypotenuse for this, since this is isosceles, that side's obviously going to be 2, but we would have 2 squared plus 2 squared is equal to c squared, and 4 plus 4 is 8 is equal to c squared, and when you take the square root of 8, you get 2 root 2. So again, you need to have good radical skills. There's no decimals for this entire video. Everything needs to be given in an exact answer. And then you would go try it again with the next one, and you would have 5 squared plus 5 squared is equal to c squared. 25 plus 25 is 50 is equal to c squared. And when you square root 50, you are going to get 5 root 2. Now you should see a pattern developing here. And that is the 45, 45, 90 right triangle pattern. So without even doing the Pythagorean theorem, I'm going to guess that you would predict that this is 12 root 2. And you would be correct. So we have a pattern here. Now you will hear different teachers tell you different ways to label the pattern. I've heard XX, x root 2, a root 2, 1 root 2. There's so many different ways to do it. There is no right or wrong way. I personally use L, and L root 2 because the legs of an isosceles or the sides of an isosceles triangle that are congruent are called legs. So these would be the leg, and this is whatever the leg is times the square root of 2. And you will have your pattern. So when you're working with it, I have a tip that I've been telling people for years, and those that use it typically do a little bit better. And what you do is inside of every one of your problems that is 45, 45, 90, you should write the pattern, the L's on the legs, and the L root 2 on the hypotenuse. This is optional, but helpful, especially when you're just getting used to it. So now I have all of mine labeled, and what you do is you just take what's given and set them equal to each other. So I am given that L is equal to 6. And once you have that, you can just substitute it into the formula for your missing sides. So we have L is 6, so here's a 6, and here's L root 2, so we have a 6 root 2, because all we have to do is substitute the L back in. Okay? In our second example, we take what's given and we set them equal. We have L root 2 is equal to 15 root 2. Now, when you're not given L, you have to solve for L. So this is like multiplication. This is like saying 2x is equal to 6. You divide both sides by 2. So L times the square root of 2, to get rid of a square root of 2, we have to divide both sides by the square root of 2. And in this situation, they just cancel. So L is equal to 15. Now that I have my L, I'm just going to plug it in. Here's L, here's 15. Here's L, here's 15. Done. That's all you have to do. So what I would like you to do is try the next two, and you're going to have a little bit of an issue with one of them, and you are especially going to have an issue with this if you are not good with your radicals. So pause the video, give it a shot, let's see what you can do. So for this one, we are given that L is equal to 3 root 3. Now, we're already done. We're solved for L, so now we just have to plug it back in. So over here is an L, so we have a 3 root 3. This is L root 2, so this is 3 root 3 times the square root of 2. All I did was substitute L as 3 root 3 in here in my formula. And now all I have to do is 3 root 3 root 2 Remember your radical skills. When you multiply radicals, you multiply outside with outside, inside with inside. So this is 3 root 6. Okay? And the last one, we are given the L root 2 side, but it's equal to 8. So we have to solve for L by dividing both sides by the square root of 2. And that's going to give us L is equal to 8 over the square root of 2. You know the rule. You cannot have radicals in the denominator. So you'll simplify and get 8 root 2 over 2. And of course, 8 over 2 divides to 4. So L is equal to 4 root 2. So L is 4 root 2 and L is 4 root 2. And you are done. Okay? So again, as you can see, if they're really easy, if we're just giving you the easy things, the pattern is really easy to work with. However, if you do not have good radical skills, you can see how problems like these last two will be tricky. It's not that the math has changed, it's just that you need good radical skills. Okay? Now for these guys, you can predict that I'm going to tell you that these patterns are similar. And they are. I'm only going to do one with the Pythagorean theorem this time. So we have our A and our C. So this would be 2 squared plus B squared is equal to 4 squared. And we would subtract 4 from 16. And we would get B squared is equal to 12. And we were square rooting both sides. And we would get B is equal to 2 root 3. So this side is going to have a 2 root 3. Now you can see that we have a 2 and a 4, and this one is now 5 and a 10, so I'm guessing you can predict that this is going to be a 5 root 3. And then you get to this one and you're going to say that this is 11 root 3 and 22. If you were to follow the pattern, that we're going to double that side and you would be correct. So again, this is a 30, 60, 90. And although the legs of a right triangle are these two sides, they're also 3 different sides. So again, I've seen x root 3, 2x, I've seen a, whatever. I use s for the short side, and then this is the short side times the square root of 3, and this is 2 times the short side. Okay, those are not 5s, those are s's for short side. Again, whatever letter you want to use for the pattern is totally fine by me. And just like the last example, if we were to go in and say that this is s root 3, and this is 2s, it might make working with these problems a lot easier. You just have to be very careful that your s goes opposite of the 30. So opposite of the 60 is your s root 3, opposite of the 30 is the s, and your hypotenuse in this will always be 2s. And if you find it helpful, I highly encourage you to use it, but again, it is totally optional. And once you have that all set up, working with 30, 60, 90s is the exact same as working with 45, 45, 90. You take what you're given, set them equal. So s is equal to 4. And now, everywhere I see an s, I'm just going to plug in a 4. This is s root 3, so this is going to become 4 root 3. This is 2 times 4, so this side is going to be 8. All you have to do is substitute your s in after you solve for it. And this one right here, we are given the s root 3 side is equal to 6 root 3. And divide both sides by the square root of 3 because we are solving for s now. And we know that s is equal to 6. So here's an s, here's a 6. Here's a 2 times s, so we have 2 times 6 is 12. Again, and as you can see, we are not having any decimals in our answers. We're leaving all of our answers exact. So if you would like, pause the video and try these next two and see how they work out for you. Click play when you're ready, and we'll be done with this video. So this one, you are given that 2s is equal to 20. So we have to divide both sides by 2 to solve for s. S is equal to 10. So here's an s, we put in a 10. Here is an s root 3, so that becomes 10 root 3 because all we have to do is substitute 10 in for the s. Last example, we have 2s is given and it's equal to 8 root 3. So we just have to divide both sides by 2 and we get s is equal to 4 root 3. So here's an s, here's a 4 root 3. Here's an s root 3. So we have 4 root 3 just for the s, and now we need to put in the other root 3 for the formula. When we multiply the inside, so 4 root 9. But we know the square root of 9 is 3, so this is like saying 4 times 3 is 12. Okay? Now that is the introduction to special right triangles. In another video, we're just going to have a whole bunch of them blended together, alternating, making sure you know your patterns, doing some with a little bit trickier radicals, taking it up to an application level, and that's about it. So anyway, for this video, we are done. This is Longo and I'm out. See you, bye.